Okay.
This demo here is called the Crook's tube. And it's very similar to how an CRT TV would work. Similar, not the same. What we have in this tube is pretty simple. First we have a heating element in here that when I turn it on will glow like a filament from a light bulb. So as current runs through the filament, it gets hot and it glows. It's not going to get that bright, but it will get noticeably bright, like red hot, not like white hot. Then I have, there's a couple of pieces here, the anode and the cathode, and I'm going to run a very large voltage. I'm going to start with about 300 volts between the two. And what's essentially going to happen is we heat up that part of the metal so that it has, so the electrons in that part of the metal have extra energy. Then we use the voltage across this anode and cathode here to rip the electrons away from the metal. Now they're being added, by a circuit, so everything stays neutral. But we're literally going to take the electrons off of this little heating element here, and we're going to pull them, through this little hole in this plate down the tube here. This tube is filled with argon gas, and so as the electrons hit the argon gas, it will cause them to fluoresce. So we'll see an illumination here with kind of a turquoise greenish blue. It's not on right now. We're going to turn off the lights here in a second so that we can see the gas as it illuminates. Then we also have a couple of plates here that I want to point out. Right now these plates don't have anything on them, but these two plates right here, I could put a charge on them, and I will put a charge on them later, and we'll be able to see that as a charge is put there, we can create a little electric field in that region, and we'll see what that does to the electrons. And then finally, I also have these two really large coils, which are not a part of the Crook's tube. The Crook's tube is just this. But I have these two coils here, and what I'm going to do later on is I'm going to run current through them. And just like current in a wire, if I have the current running from positive to negative, I'm going to have the current running this direction. So with the right-hand rule, your thumb would be pointing this direction, so the magnetic field would be going this way. And likewise over here, I have a similar thing, so the two magnetic fields add up. So if you put a compass in here, like the North Pole would point that way. So I'm going to use these two to make a magnetic field in this region, and we'll see how the electrons interact with that. All right, so let's go ahead and turn off the lights. And I'm going to turn on both of these powers at the same time. So for the heating element, it's running about 6.3 volts, not very much. And then for the anode and cathode here, like I said, it's about 300. And you can see as the beam comes on here, you can see the beam right here in the tube, right? So now the first thing I'm going to do is, these are literally electrons, and there's all sorts of fields and things going on, but right now they're shooting out and they're spreading out a bit. So what I'm going to do here is I'm going to use this this voltage, this power supply it's doing 300 volts here, and I'm going to change it. So the first thing I'm going to do is I'm going to increase the voltage. So I want you to see how this changes here. So as I increase the voltage, we notice that the path kind of gets larger, and as I decrease the voltage, we see that it gets smaller, right? And so by varying this voltage here, I can vary how wide the path is horizontally.
Or do it again.
Also notice that as I change my voltage, it gets brighter and dimmer, because this voltage is what's literally causing the electrons to come off of our heating element. All right, so we'll put this thing back to about 300. Okay. So now, remember, these aren't electrons you're seeing, but it's the luminescence from the argon gas, but it's caused by the electrons slamming into them. So it's not electrons, but it essentially is. Now, what I can do is I'm going to turn on this other power supply here. And these two plates that I mentioned earlier, the vertical ones, I can charge them positive or negative, however I wish, with this power supply. And so let's see what happens. So if I have electrons going through here, and I put negative on one plate and positive on the other, it's going to be repelled from one and attracted to the other. So if these are electrons, essentially, that we're looking at here, as I increase the voltage here, note what happens to the beam. It's deflected up. So what this means is if you have electrons here, that means this top plate has to be positively charged and the bottom has to be negative because the electrons are bending away from the negative towards the positive. Now they're going with a pretty good speed, so they don't just go straight to that other plate. They're just bent towards it. All right, so here I can turn this voltage down and it goes back to the center. So now I'm actually going to switch the power here so I can make the bottom plate positive now. And so when I increase the voltage, you notice that it goes down further. All right? All right, now, I'm going to turn that off. We're done with that electric field. So now let's go to these coils here that we talked about earlier. I'm going to turn on this power supply. I'm going to run AC through it. No, not AC, DC. DC because I want a constant field. I don't want the field to change. So again, right-hand rule. Current's going to go in this direction, magnetic field's going to go this way, okay? But here's the thing, the electrons are going this way. So let's increase that voltage. So notice that with the current running in this direction, magnetic field's going this way, the electrons are going down. So, as I increase this, we can see that pretty easily changes it, and I'm not using that much current. I mean, even at this point, the current in these coils is only about 0.65 amps. And that's between both coils. And so again, I can switch my current, and I can cause the current to go in the opposite direction. So if I do that, the magnetic field from the coils will be in the opposite direction. So now the magnetic field should be in this direction. Again, these are essentially electrons we're looking at, and I can do this and I can bend it up again. So I said that this is kind of like a TV, like a CRT TV, and essentially in a CRT, it's a cathode ray tube, and you're sending electrons down the tube, and you're using a combination of electric and magnetic, mostly magnetic fields, to divert these electrons to different parts of the screen. And depending on how you build it, you get different colors. I'm not getting into all that, but hopefully you can kind of see that we can use these electric and magnetic fields to steer the electrons. Now, the last thing we're going to do is we use an electric field to move this, and then we use a magnetic field to move it. I'm going to use a magnetic field to move it again, but this time instead of using electricity to create a magnetic field, I'm just going to use a magnet, because essentially it should do the same thing. So I've got this magnet here, and I'm just going to bring it near it. So notice here I'm not just, here if I just go towards it and away, I get essentially the same behavior I had before, right? Going parallel. But because it's a magnet, I can just move it anywhere I want. Now it's a bit more complicated. It's not moving in the same direction I'm moving, but there is a response. And so notice, like here, it's going down as I move towards it, but if I turn the magnet around, it goes up now. But here I have a whole three-dimensional field to play with. All right, and that's it for the Crook's tube demo.